Hello students, here are the 3 marks questions from vectors chapter. Say, first question I have written. If A vector, comma B vector and C vector are 3 vectors such that magnitude of A vector is equal to 3, magnitude of B vector is equal to 4 and magnitude of C vector is equal to 5 and each vector is orthogonal, means perpendicular to the sum of the other 2 vectors, then find magnitude of A vector plus B vector plus C vector. See, first I have written the formula. Magnitude of A vector plus B vector plus C vector, the whole square. This is equal to magnitude of A vector square plus magnitude of B vector square plus magnitude of C vector square plus 2 into A vector dot B vector plus 2 into B vector dot C vector plus 2 into C vector dot A vector. See, this is the left hand side and from here to here is the complete formula. Now my dear students, I will explain meantime this. Each vector is orthogonal to the sum of the other 2 vectors means what? Each vector, for example A vector, is orthogonal. Orthogonal means perpendicular to the sum of other 2 vectors. So for A vector, the other 2 vectors are B vector and C vector. What is the sum of B vector and C vector? B vector plus C vector. Therefore A vector is orthogonal to B vector plus C vector. A vector is perpendicular to B vector plus C vector. And all of you know, when 2 vectors are perpendicular or orthogonal, their dot product or scalar product is 0. Therefore A vector dot B vector plus C vector is 0. Therefore I will start from that first. Listen. See my dear students, they have given A vector is orthogonal or it is the same as to say perpendicular to the sum of other 2, that is B vector plus C vector. This meaning is, this means, see A vector dot B vector plus C vector is 0. Similarly, they have given each vector, say for example B vector is also orthogonal. Orthogonal means I will write perpendicular. Perpendicular to the sum of the other 2 vectors. To B vector, the other 2 vectors are A vector and C vector. So their sum. So A vector plus C vector. And this implies, see when 2 vectors are orthogonal, their scalar product or dot product is 0. Therefore this implies B vector dot product A vector plus C vector is equal to 0. Also one more case. C vector is perpendicular to sum of other 2 vectors. Which are the other 2 vectors for C vector? A vector and B vector. Therefore C vector is perpendicular to A vector plus B vector. Therefore C vector dot A vector plus B vector is also 0. Now my dear students, I will add these 3 equations, say like this, here itself. That is why I have written them, say one below the other. So when I add this A vector, therefore A vector dot product B plus C plus this plus, so this dot product B vector dot A plus C and plus this dot product C vector dot A plus B is equal to 0. Now I will apply dot product is distributive over addition. That is I will apply A vector dot B vector plus this A vector dot C vector plus B vector dot A vector plus, look at this, B vector dot C vector. This plus, look at this, C vector dot A vector plus, look at this, C vector dot B vector is equal to 0. Or in other words, say this A vector dot B vector, the scalar, and B vector dot A vector are same. Why? Because B vector dot A vector is equal to A vector dot B vector, because scalar product is commutative. Therefore, B dot A same as A dot B. Therefore, I will add A dot B and this B dot A, and I will write 2 times A dot B plus. Similarly, I will add this A dot C plus C dot A. So this becomes 2 times A vector dot C vector. This plus, let me add these two, B vector dot C vector plus C vector dot B vector. That is 2 times B vector dot C vector. This is also 0. So this is one intermediate result we got. Now I will teach you how to find magnitude of A vector plus B vector plus C vector. That is why I will continue remaining part of my solution here. Say I written the formula already. Magnitude of A vector plus B vector plus C vector whole square you find, and the formula is magnitude of A vector square plus magnitude of B vector square plus magnitude of C vector square plus sum of these three terms, and this I will start substituting. Say magnitude of A vector square, say they have given 3, so 3 square plus magnitude of B vector square, say 4 square plus magnitude of C vector square, say 5 square, and from the remaining 3 terms I will take 2 common, 2 into, first from the first term A dot B remaining, plus from the second term B dot C remaining, plus from the third term C dot A remaining. And my dear students, this is easy. 9 plus 4 square 16, so 25 plus 25, so 50. This plus 2 into, this by the way, 2 into A dot B plus B dot C plus C dot A. See, we got it here. In fact, this is my, say, equation 1. So this is nothing but 0. How? Because it is from equation 1. Okay? Or if you don't want, you don't take 2 common. Directly we have this, but that entire sum is 0 because of equation 1. Thus, I got magnitude of A vector plus B vector plus C vector whole square is equal to 50. This 50 plus 0, 50. Therefore, magnitude of A vector plus B vector plus C vector is equal to square root of 50. Only positive square root of 50, no minus. Therefore, no plus or minus, only plus root 50. And this we can simplify further. This 50 can be written as 25 into 2. And this is square root of 25 is 5 root 2. So this is the final answer. So watch the video carefully and understand. So dear students, here is the next very important 3 marks question. Kindly read the question. Find the unit vector perpendicular to each of the vectors A vector plus B vector and A vector minus B vector, where A vector and B vector are given. So here I have written the formula. A unit vector perpendicular to each of the vectors A vector plus B vector and A vector minus B vector is, first to find their cross product, vector product of A plus B and A minus B. That will be a vector in the numerator, divided by find its that vector's magnitude. That is our answer. So I will briefly tell you the steps involved. First step, find a vector plus b vector. You need to add the vectors given. Second step, a vector minus b vector. You need to subtract b vector from a vector. Then you find cross product of the two vectors, a plus b and a minus b, using that determinant definition. Then you have to find fourth step, magnitude. Then fifth step, you have to divide one over another. So I will start by finding a vector plus b vector. Say a vector plus b vector is, see, a vector is 3i plus 2j plus 2k, plus b vector is I plus 2j minus 2k. On adding this, I will get, see, 3i plus I, see, 4i, and 2j plus 2j, see, 4j, and 2k minus 2k gets cancelled. So there is 0 times k only. It gets cancelled. Therefore, it is nothing but 4 comma 4 comma 0. On the other hand, I will find a vector minus b vector. So a vector is 3i plus 2j plus 2k. This minus of b vector is I plus 2j minus 2k. One can easily subtract here itself. Say 3i minus 1i. So 2i. This is 2j minus 2j gets cancelled. So 0 times j. This is 2k minus into minus plus 2k. So it is 4 times k. Yes, therefore this is ordered triplet 2 comma 0 comma 4. Now I will find a plus b cross a minus b. Therefore, look at this. A plus b vector cross product with the vector a minus b, and it is the determinant definition whose first row is I, j, k. Second row is vector a plus b. A plus b is, say, this 4, 4, 0. I should write over here. Third row is a minus b 2, 0, 4. 2, 0, 4. And I will expand it in front of this over the first row. Say I cap into the 2 cross 2 determinant obtained by deleting row and column containing I cap. So 4, 0, 0, 4 remaining. This minus j cap into a 2 cross 2 determinant 4, 0, 2, 4. 4, 0, 2, 4 plus k cap into a 2 cross 2 determinant 4, 4, 2, 0. 4, 4, 2, 0. Therefore, this becomes I cap into, say, 4 into 4, 16 minus 0. Then minus j cap into, this is, say, 4 into 4, 16 minus 2 into 0, 0 itself. Plus k cap into, say, 4 into 0, 0 minus 2 into 4, so minus 8. Therefore, my dear students, shall I say here, it is 16i minus 16j and minus 8k. Or shall I take 8 common as a scalar? It will be 2i minus 2j and minus k. So this is in fact the numerator. Now I will find its magnitude. Therefore, magnitude of a plus b vector cross a vector minus b vector is equal to, so magnitude of this right hand side, 8 into 2i minus 2j minus k. And while finding magnitude, so first comes magnitude of 8, modulus of 8. 8 is a real number. So modulus of 8 first, and into magnitude of this vector 2i minus 2j minus k. And now all of you know magnitude of 8 is already positive, so it's 8 into magnitude of 2i minus 2j minus k, square root of, say, 2 square plus that of minus 2 square plus that of minus 1 square. or this magnitude, we get, say I will adjust here itself, 8 into, say this is square root of 4 plus 1, square root of 9, which is 3. Therefore this magnitude is 24. Then I will substitute in this formula. Say formula I have written already. So this is the formula. I request you, please commit to memory. Watch the video carefully, and in this formula, therefore I will substitute n cap is equal to, and the numerator is a vector which I have got here, 8 into 2i minus 2j minus k divided by the magnitude. Magnitude is 24, and 8 goes here in 24 3 times. Therefore the final answer is 2i minus 2j minus k upon 3. So kindly go through the solution. Dear students, here is the third question, and this is called the section formula for internal division using vectors. The question is, the position vector of the point P, which is unknown, we should find, which divides the line joining the points A and B, having position vector small letter A vector and vector B. Okay, that is position vector of A with respect to origin is A vector. Position vector of B with respect to origin is B vector. And the division is internal. Who divides? The point P divides the line joining A and B internally in the ratio m is to n. So this should be our answer. So this we are supposed to prove, and in this proof the diagram is a must. So therefore, dear students, look at this. I will take origin here. This is O, origin, and its position vector or position vector of point A. So here I will mark terminal point of vector OA, and this position vector OA vector is given to be small letter A vector. So this arrow writing is a must. So A vector. Next, see, with respect to origin itself, the position vector of point P, B, say this is B. So this point capital B, and this is the direction from O to B, and this position vector, writing this arrow is a must, is given to be B vector. This position vector OB vector is B vector. Then let me join AB. Say I will join this AB, and on AB there is the point P. So assume I will mark it the point P here, and we need position vector of P, which I will mark or I will draw like this, and for simplification purpose I call it small letter R vector. Now what this point P does? P divides the line AB, see, internally. Yes, it is almost in between A and B in the ratio m is to n. That is AP scalar is m, PB scalar is n, PB is n, and I will mark a direction from A to B. Say somewhere here I mark the direction. Therefore, marking direction, writing these arrows 1, 2, 3, and this arrow at least once here, very, very important. So I will write here briefly. OA vector is equal to A vector, comma, OB vector is equal to B vector, and OP vector is equal to R vector, are the position vectors of the points See, the points are, my dear students, capital A first, comma, capital B and capital P last. With respect to O, O means origin, respective or initial point. So this sentence is not so compulsory to write in the proof in the exam, but if you want, you can write this. Now I will start my remaining part of the proof here. See, from the diagram, it is very clear that if you take AP divided by PB, say I will write here AP divided by PB is equal to M by N. And my dear students, here do not write vector symbol, do not write AP vector, do not write PB vector. Just it is AP by PB, ratio of scalars. This is M by N, ratio of scalars. But I will cross multiply. N I multiply to this AP and this PB I will multiply to M. The moment I multiply, it becomes N into scalar into this AP I will write as vector now. N into AP vector. Is it meaningful multiplication? Yes. It is multiplying a vector which is AP vector by the scalar N. N is a scalar. So scalar multiplication of a vector it is. That operation. Not ordinary multiplication. It is scalar multiplication. Multiplying a vector by a scalar. This is equal to here. This M scalar and I multiply to PB. I will make it a vector. PB vector. Now, you know, AP vector definition is OP vector minus OA vector using our triangular law of addition. Okay, in this triangle OAP, I will repeat, AP vector is, in fact, you will get OP vector minus OA vector. Just otherwise you need to remember it as a formula. It is a definition. All of you know. Position vector of point P with respect to O minus position vector of point A with respect to O. Which point comes second? P comes second. Its position vector first. Minus A comes first. Its position vector second. Similarly here, M into this PB vector is OB vector minus OP vector. And now I will substitute. It's N into see, this OP vector is R vector. See here, N into OP vector R vector minus OA vector A vector. This is equal to M as it is. Look at this OB. OB vector is B vector. B vector minus OP vector is R vector. Now I apply, that is this scalar is multiplied to this vector, of course, scalar multiplication, but I will here open the bracket. It can be further written, maybe N into R vector, nothing wrong in this, and N into minus A vector. This is again scalar into vector. This is M into B vector. This is a property, in fact, and plus M into minus R vector. Minus M R vector, or I will write this as N R vector, let it be here itself, minus M R vector you transpose, it becomes plus M R vector, and here this M into B vector as it is here itself, minus N A transpose, it becomes plus N A vector, or R vector here I may write like this. And I may write scalar inside, M plus N. Even this is same. Multiplying a vector by a scalar, or scalar multiplied by vector. Right hand side same. M B vector plus N A vector. Or my last line, I will write here. Therefore, R vector is remaining. This R vector is equal to M B vector plus N A vector. This is as it is. And since, my dear students, this is a scalar multiply. M plus N is a scalar, not a vector. Therefore, easily we can take it, bring it to the denominator. Divided by M plus N it is. So, that is the required position vector. So, watch the video carefully. Kindly go through the proof. Dear students, from the vectors chapter, we are solving the 3 marks questions, and here is the 4th question. Find the area of the rectangle whose vertices are given. Capital A of minus I plus half j plus 4k, comma, capital B of I plus half j plus 4k, comma, C of I minus half j plus 4k, and D of minus I minus half j plus 4k. So whenever vertices are given, these are the position vectors, not the sides. That means I have to write this as OA vector, this is OB vector, this is OC vector, this is OD vector. So I will start writing like this. A given OA vector is equal to, and I will write this, say minus I plus half j plus 4k, and this is coordinate wise or component wise, component form. I can write, say, coefficient of I minus 1, coefficient of j cap half, coefficient of k cap 4. Next, this is OB vector. See, OB vector is equal to I plus half j plus 4k, I plus half j plus 4k, and this is equal to the order triplet 1 comma half comma 4, and this is OC vector. OC vector is equal to I minus half j plus 4k, I minus half j plus 4k, and its coefficients are 1 comma minus half comma 4, and the last one is OD vector is equal to minus I minus half j plus 4k, and this is equal to order triplet minus 1 comma minus half comma 4. Now I will find out to see AB vector and AD vector. So I will continue my solution over here. So first I will find out AB vector, and you know the definition, OB vector minus OA vector. So OB vector is, say, 1 comma half comma 4 minus OA vector minus 1 comma half comma 4, and all of you know subtraction of vectors. See, 1 minus of minus 1 plus 1, so 2 it is. Half minus half, say 0. 4 minus 4, 0. Also, I may find BC vector, nothing wrong, but do not go for AC vector. So instead of finding BC vector, I will find AD vector. So AD vector is equal to OD vector minus OA vector. So OD vector, see over here, minus 1 minus half comma 4 minus OA vector minus 1 half comma 4, and therefore this is minus 1 minus of minus plus 1, so 0 comma minus half is minus 1, and 4 minus 4, 0. And then I will continue remaining part of my answer, say here. Therefore area of rectangle ABCD, rectangle ABCD, and I will follow this formula. See, magnitude of AB vector cross AD vector. See, I have AB vector, I have AD vector. Therefore, first I will find this vector AB vector cross AD vector, and it is a determinant definition. First row I, J, K. Second row AB vector, say 2, 0, 0. 2, 0, 0. Third row is vector AD, 0, minus 1, 0. And if I expand this, you can easily expand it over second row because two elements are already 0. Or you can easily expand over third row because two elements are already 0. But I will expand it over that of the first row itself. I into determinant 0, 0, minus 1, 0. Minus j into determinant 2, 0, 0, 0. Plus k into determinant 2, 0, 0, minus 1. So we will get this as nothing but 0i, 0 into I cap. This is also 0 into j cap, 0 into j cap. Finally, minus 2k cap remaining. Now I will find its magnitude of AB cross AD vector, which is square root of 0 square plus 0 square plus minus 2 square. So square root of 4, which is 2 square units, is the area of this rectangle. So watch the video carefully and understand the solution. Dear students, here is the fifth 3 marks question. 3 vectors, A vector, vector B and vector C, satisfy the condition vector A plus vector B plus vector C is equal to 0 vector. Evaluate the quantity A vector dot B vector plus B vector dot C vector plus C vector dot A vector. If magnitude of A vector is 1, magnitude of B vector is 4 and magnitude of C vector is 2. So this is the formula necessary. Say I have written the formula. Kindly go through. Magnitude of A vector plus B vector plus C vector whole square is equal to magnitude of A vector square plus magnitude of B vector square plus magnitude of C vector square plus 2 times A vector dot B vector plus 2 times B vector dot C vector plus 2 times C vector dot A vector. Say this magnitude of A vector plus B vector plus C vector, I will put magnitude of 0 vector square because A vector plus B vector plus C vector given to be 0 vector. And this right hand side, magnitude of A vector square 1 square. So this is 1 square plus magnitude of B vector square is 4 square plus magnitude of C vector square is 2 square. Now from the remaining scalar products, or they are all scalars, I will take 2 common in bracket A vector dot B vector from the first plus from the second B vector dot C vector remaining plus from the third C vector dot A vector is remaining. This is magnitude of 0 vector is 0. 0 square is 0 itself. This is 1 square 1, 4 square 16 plus 2 square 4. 4 plus 16, 20 plus 1, 21 plus 2 times same it is. A vector dot B vector plus B vector dot C vector plus C vector dot A vector. Now this 21, I will get this side. So minus 21 and this is equal to 2 times our required quantity. Required quantity is A vector dot B vector plus B vector dot C vector plus C vector dot A vector. Or my last line is this A vector dot B vector plus B vector dot C vector plus C vector dot A vector. I will keep it here itself as it is, and this is minus 21. This too I will get it to the denominator. So the required answer is minus 21 by 2. So such a simple solution. Watch the video carefully and understand. So I hope you have understood these 2 marks and 3 marks, the very important questions I solved from vectors chapter. It will be really useful for you in your all type of exams, including your board exam as well as competitive exams. Thank you very much.